operating data pipeline with Airflow. How many of you are using Airflow in production now? Oh. How many of you are like operating Airflow? Max, come on. I'm Ananth. I'm a data engineer at Slack. I'm going to talk about operating data pipeline. So 6 months back, we started an on-call rotation for our engineers. Before that, we didn't pay much attention to our SLA and other things. And we started to witness and all the issues that started to bubble up. And we started to say, okay, we're going to fix it. And this talk is about what are the incremental steps that we took in order to make our on-call, quote unquote, easier. So about Slack, public launch in 2014, more than 1,000 plus employees working now. Diverse set of industries like software, technology, retail, you name it. So this is a brief history of a data engineering team. So we started in March 2016. That's when like 5 people from different group of engineering teams started like, okay, we're going to start a separate data engineering group. By the time, Slack's already 350 plus employees, and we already have 2 million active users. And fast forward, April 2018, got 10 data engineers. If you count managers, that's 12, but I don't know if they count. We're on like 1,000 plus Slack employees, and we have 6 million active users. And you can see the ratio between number of Slack employees versus number of data engineers that we support on a large scale data infrastructure. The data usage, 1 in 2 per week accessing our data warehouse system in some way, either they're coding or building data pipeline one way or other. And we have around 500 plus tables right now in our warehouse. Some are secure, some are de-anonymized data. And we're about getting 600K events per second in our event pipeline for all those events collecting. Apart from that, we take daily snapshot from our operational stores. We're around 700 shots of MySQL instance now. So every day we pull a snapshot from operational data and create tables for that, for batch analysis. So Airflow stats, we have around 240 plus active DAGs. We're running about 5,400 tasks per day. And there's like 68 contributors. Now, I put the stats for a reason. If you look back, we are about only 10 people team. But for Airflow, you can see there is a 68 contributors actively building data pipeline or engaging with our repo. That really tells how much the tool democratizes our data access and everyone trying to contribute back and building the system. Right? I think that's the greatest achievement for Airflow community, I would say. So thank you. So agenda for the talk today, I'm going to give a brief intro about like what is our Airflow infrastructure look like, and some of the things that we did to scale Airflow Executor, and some of the pipeline operation techniques, and what are the things that we do for alerting and monitoring things. So Airflow infrastructure.
Okay.
We're running on local executors, so no fancy distributed things. Still on local executors, works for us. So tarball-based code deployment. We used to have a Git-based deployment before, but we're slowly moving to a monorepo. So we are merging all our data infrastructure-related repos into one single repo. And a continuous deployment of Jenkins and Flake8 and Cypress for all those code management and other things. I want to point out that Airflow.sh is like a small shell utility to ensure consistent development environment across all the users. Now, that's the most critical thing that we've done. If you look back, we have 68, almost like 7x of contributors contributing across this organization, and it is important for them to bootstrap quickly and try to contribute. So learning curve and ability to build the system should be very fast. So we build this small utility shell script that just single command, Airflow get installed, you get all the permissions and other things. So the users can locally test it, the DAG and validate it, like whether the task is rendering, all those things. So this gives a nice little utility for them to push code to the repo with high confidence. The Airflow service runs on the local, but when you do Airflow test, it runs on the dev instance. So scale Airflow executors. So 6 months back, and we're running on local executors, and there's a constant complaint. Why my task is running? I'm sure like most of the things you have heard every day if you are working with Airflow. Like Airflow deadlocked again, Airflow not scheduling any tasks to me. And then our response always like, okay, it's Airflow just being Airflow. It's totally weird. And we started to look back and see like, okay, we can improve a lot on those things. Then we started to profile systems, and this is a CPU usage of a typical local executor in our system. And you can see here at the right this 4 o'clock, there's a heavy hit on the servers, and the CPU get overloaded, high CPU usage, and process maxed out. Airflow scheduler not able to spin off any more processes. What is really happening here is we take snapshot every day across all of our MySQL instances, and there's a whole bunch of tasks, the daily tasks, waiting for those tables to arrive. And so this is 4 p.m. Like all our snapshots running on the UTC timestamp. So there's like 12 o'clock in the morning, all the daily tasks, spin it off and waiting for that. And it just kills the servers. And we started to examine, so what is really happening here? So there are a lot of external, tasks that wait for other DAGs. And it just, the way Airflow sensors works as a design right now, it's like the process invoked and it checked whether the success condition met, or there's no external task sensors we succeeded, or the file not available, and it goes to the sleep and then poke around after like specified interval and try to see what is happening. But the process is still alive and the process doesn't yield. So when the daily task started, like there's a whole bunch of tasks, wait for tasks getting spin off, and then they just occupy the task slot and it is not yielding for any other task to run. So that leads to a lot of issues, like there's always a deadlock. Like one task depends on other things, but the other task got scheduled initially and it is not yielding, and there's a lot of tasks getting into the queue state. Some that wait for, like the running task wait for the queued task, and it's like whole mess. So someone has to have a complete understanding of what is a 240 DAX pipeline look like, and they have to kill the task that kind of interdependent, or otherwise kill everything, hoping that it will solve our issues. So we decided that, okay, we can do better. What we can do, that's when we introduced the retryable sensors. So basically the idea is here is like, okay, the sensors starting and then checking for the success condition. If that is not successful, it doesn't need to be holding the process. It can yield the process and it can die and it can retry. And Airflow has a retry functionality that you can try. So we just time out and then make them to retry again and again. So multi-retryable sensors, this is a syntax typically look like, is like, you can define multiple wait fors for a particular DAG, and there's one process that get executed and check all the condition that it needs to be executed. And then once the condition is satisfied, it just yielded. So once we rolled out, and you can see the CPU usage here, right across the 4 p.m. time, you can start to see this nice little sine wave. That means like the executors basically get killed. Oh, sorry, the sensors getting killed and trying to constantly retry, and that yield other tasks to run. That's worked for us because we are using local executors. For Airflow scheduler to spin off a new process is less cheap, like less expensive than just holding the process and waiting for that, right? It may not be true for some other executors, but certainly holds true in local executors, right? So that solves a lot of problem now. The yielding and those things, we no longer face any deadlock issues, and schedulers started to work as expected and as we on our scale. The one caveat you have to look if you are going to try out this approach is if you are using S3 or any file systems that store your logs, the way the exports works in the log is like you take the whole bunch of logs and then push it. So now you are retrying indefinitely for all the tasks. And what we notice sometimes if the task, like if any external task struck for like 24 hours, and then after 24 hours, you have to export the whole log. So it just load into the memory and then let's push it that one. It's kind of killing our memory usage. So we just turned it off, exporting S3 logs to fix this one. So that's how we kind of make scheduler a little more reliable. And the next one is pipeline operations, right? So if you're operating Airflow, these are some of the things that you have to be very mindful of. The notion of believing upstream tasks success is reliable is totally wrong. And then the task remains static after the success state. It's never going to be. There are a lot of times you will see some calculation goes wrong or something, some bad data get generated, and it says the task says success, and the downstream jobs keep running. And after some point, you basically find the bugs after like 5, 6 of downstream jobs, and you find, oh, this is wrong. So where is the problem? And you're tracking down all the way to upstream and say, oh, okay, this is wrong. I fixed it. Now I wanted to rerun the whole thing, right? So these two things will always happen when you're doing when you're operating systems. And the notion of DAG structure is static never holds true. Like people always, the DAG will always evolve. There's a new task getting added, task getting deleted, and it's never be static. The data quality is not part of the task lifecycle. It is strictly a part of a data lifecycle. I think this is one of the recurring complaint I'm going to give for like that task lifecycle depends on each and every system's workflow versus Airflow function, like scheduler functionality. Right now it is kind of tightly coupled, that kind of confusing a bit. So these are the 4 things that has to be very mindful of it, right? So what the problem happened for us when you are operating, we are not running like one DAG, we have 240 plus DAGs, right? So there is one DAG that produces bad data, and then you found out after 4 or 5 like downstream jobs, and now you need to go back and find out all the tasks who's responsible for that, like what are the upstream tasks, and you have to clear everything. That's most painful. Like Airflow gives nice UI but the visibility of your operations always within a DAG level. It's not a global level. But when you're operating a data pipeline, you're operating the whole pipeline. You're not bounded to one particular DAG, right? So that's one of the biggest issue that when you're facing when you're operating Airflow. So this is one of the recurring things that we face when we are operating. So it's like a total pain for that. So how do you solve that? So we introduced a tool called Mario. So Mario is like a global DAG operator. So what Marios do that, it's a nice little command utility. It can examine the whole graph the same way Airflow schedulers do. Like it build up the whole universal DAG structure, and it will try to find what is my downstream and what is my upstream. So it has a nice little commands, like you can say, okay, Mario, clear downstream. Like I have some issues. Show me what are the downstream jobs that I depend on, clear it, right? And So this gives a global visibility, and it is very helpful for us when you're operating. And when you find some bugs and we wanted to quickly clear it and then restart the whole data pipeline, this tool comes very handy for us. The other things that we introduced, some of the Airflow operations. So as I mentioned, the DAG is never static and the task always evolve. And when you have a 240 plus DAGs and like 68 plus contributors, you never notice that there is some particular task being depend on somebody else depending on the task, right? You won't have much visibility on what is going on that, and you might delete the task, or you might rename the task, or like the task no longer maybe exists. So what we did is introducing a sensor called high partition sensors. Basically, what it will do, it will check whether the task instance success, or it will check whether the data is exist in the high metastore, whether the partition exists in the metastore, or it will check the S3 file and say, oh, is that in success files already exist? So we introduced a three-way check just to be safer side. So in case if somebody accidentally did something on a particular DAG, we can still met the success criteria and then start running in. We face this issue a lot of time when we are trying to do a backfill. And the current DAG is dependent on particular task, but that task might have been introduced very late, but the files or the partitions already existed, and it can be it could be backfilled by either a backfill task or like scheduled as a separate DAG. So we wanted to make sure that we wanted to cover everything. So high partition sensor operators kind of trying to check the success condition in all those cases. And we introduce DQ check. Basically, a DQ check is an operator's nice little utility that you can write your data quality sequence. So when the task completed, it'll run the DQ check for you. And if and only, like you can configure, like whether it's a warning or it's a strictly an error, you should not, you should make the task fail. You should not run any further. So all those configurations that you can do, and it also support. I think the slide shows only is positive checking, but you can also configure like range and other sort of conditions as well. So you can do it. One thing we noticed, like the DAGs comes and go. Like many folks push the DAG and those things, and there is no way you can clean up the DAGs. And what we noticed, like we just filed up DAGs for a long time, and then Airflow DAG parser try to slow down because it has to insert the task instance, and there's a whole lot of MySQL instance getting slowed. So we did a small utility that every daily on that basically verify is there any inactive DAG is no more usable, and then if it is not in the DAG back, so it will check the DAG back whether the DAG is alive. If not, it will just delete all the tasks from the reference from the table to make sure it's working fine. And we also introduced a bunch of DAG Policy Validator. So what is DAG Policy Validator is, it's a nice little PyTest that runs every build that you push and validate the whole DAG to make sure that DAG met certain criteria for us. So we started like allowing like everyone to contribute, and then that's a whole mess. Like nobody DDoS our system, then our own developers. So we started having all those policy validated to make sure that our DAGs consistent across our systems. So some of the rules that we have is basically, if you are depending on certain external task sensors, it will validate whether the task is already exist or not. So that way we can verify you are not accidentally ingesting some dependency that doesn't exist, right? And also testing a circular dependency, that's basic thing that because you have a number of different tags, you don't want it to get into a circular dependencies and wait forever. And test priority weight. This is another thing, it's very key. So what is priority means is, the priority score is basically the yarn queue priority. So we started to tie up all the yarn priority task into our Airflow task. So when Airflow submit the task, it says, "Hey, I'm this task, and I'm a production DAG, and I belongs to a production DAG, and this is my priority weight for you. So allocate me a special queue for me so that I can run fast, right?" So the test priority weight says, okay, if you're a production DAG, you should have a priority weight. So this is just one more validation to do that one. Yeah. So no, you should don't, because so there are certain tasks that we committed an SLA to our clients. Let's say billing stats. Billing stats is super critical, and we committed an SLA for them. So whatever the task that has, whatever the table that has an SLA and all the downstream jobs is super critical for us. So that's how we propagate our task into that one. So if some users comes and say like this table that I am promised to deliver to certain users, a certain business that I wanted to deliver by this time, then that goes to the production DAG, and we evaluate the priority for that and then adjust that things. Yeah, test on failure. This is one of the things. So we had an issue one time, like during the on-call. So somebody introduced a new dependency in the production DAG pipeline that doesn't have any alerts. It doesn't alert us on failure, or doesn't alert on anything, and just died. And we noticed only after the SLA misfired, and we kind of hunting it down and say like, oh, this stops failed for a long time and it didn't alert anything for us. So all this, so this validator basically verify all the 240 plus DAGs and say, okay, these are the production DAG, this is the production downstream, this is an upstream, whether it has all the alerts, everything properly set for that. Yeah, the same thing aligned with that. Like, okay, if you're a production DAG, you should have an alert, you should have an SLA defined, you should have an SLA timing, because let's say your task, like you are an upstream, two different tasks is one depend on another, have a same SLA is make no sense. So this is something that we always check to make sure that we have a meaningful SLA across our DAGs. And the other thing is, we are enforcing, if you are pushing some task as a production DAG, then it should have a DQ check. And it should have a retry and success callback. Things can fail, Airflow retry always, but we wanted to be sure if once a retry happens, we need to alert back if the success done of those things. So all those things are super critical for us to make sure that, so the tail rear of this, all the DAG policy validator, if you are running a production DAG and if your task bounded to an SLA, all your upstream tasks should be of a high priority task, and all your upstream tasks should have a certain like failure notification. Everything has to be aligned on that thing. So this checking is make sure that our DAGs maintain the sanity. Yeah, so that's operating things. So once we start to enforce things that makes us a lot more easier for us to operate data pipeline. Now we know what should alert and what should not alert and what should run as a high priority things. So now that boils down to, okay, how do I alert and monitor? Like once we do all the sanity check, how can I alert and monitor it, right? So these are the design constraint that we took. Airflow has enabled features that you can alert on the pager duty or an SLA miss and all sort of things. But as I mentioned, like we are running on a global operations, right? Like all the global DAGs needs to be operated. So yeah. So one thing on this, like alerting on monitoring, is like SLA is a very good SLA is a very good indicator for measuring how efficiently you are running, but that doesn't guarantee you that you are in trouble, right? Like you don't want to get a SLMS alert at like 3 a.m. and your DAG still running. Like there is something happened before, and then there's some genuine lack of the system. The task is catching up, but you don't need to get alert. Like the task, there is nothing failed, and you don't, even if you wake up just an SLMS, you can't do anything, right? You just acknowledge and go back. So we are very mindful of all those alertings and say, okay, the alerting should be reliable and alerting should be actionable, like, and alert when really matters and suppress repeatable alert. That's the 4 design goals that we took it. Let's say we got an SLMS for something, and then we don't want it to repeat again and again. And also for failure conditions, we don't want it to get alert again and again because we know and we already acknowledge it, and we are working on that, right? So, so this is what we introduced. So we create a nice little callback. This is a standard callback that if you have to integrate alerting and monitoring, you have to basically use this OnCall Alert callback. So the structure of the OnCall Alert callback is basically, okay, what is the channel that I should alert, and what is the priority of the alert, and what is the escalation chain for the on-call engineers, and what is there any notes that you have to put, like give more information to on-call engineers, and what is a resource, like where is the runbook, and what is a PagerDuty email. So the alert basically contains all the information needed for the on-call engineers to go and troubleshoot. The moment you see the alert, you should know, like, okay, this is something goes wrong, and then you should be able to go and figure it out quickly without troubling anyone. So this is some of the, and we, thanks to Airflow plugin operations, like we integrated all those on-call dashboard. That dashboard basically says how many tasks that we missed SLA for this 1 week, how many failures we got from a production task, and all sort of information. And we have how efficient we are running our data pipeline, and all sort of metrics basically coded from Airflow DB, and then we just plot it out. So every week we review that, and like, okay, what's going on, like how good we are operating, can we improve, where is the bottleneck comes in, all sort of things. And we have a specific run for each and every task. So we listed out, okay, if this happened, do this, and all those things. So this is a sample alert look like. This is a sample SLMS alert. So you can see here, okay, SLMS for this DAG, and you can see in the notes, this is a core pipeline. No downstream task will run until this task succeeded. This is the escalation chain, and you can see what is the on-call playbook and what is the priority for that alert. Right? So this gives a clear information to an on-call engineers and say, okay, this is what's going on. This is how I want to figure it out, and this is how I need to fix it. These things. This is another sample alert from data quality. Check, okay, this is a warning, and it clearly says, okay, this is not a blocking task, or a failure can happen due to fluctuation of values in the stats. This is totally normal. Don't restart or clear the Airflow task. Let it be, and we can investigate later why this is happening. So this goes to the warning, and then say, and it also says, okay, this is the failed column that basically the DQ check failed. If you're curious, go and investigate, but don't do anything, no action needed at this point. At the same time, the data quality check is super critical, and we say, okay, the same kind of alert, you should go and fix it. There is something wrong. And the triage resources basically says, okay, customer stats runbook. This task belongs to a customer stats pipeline, and this is where you can find the runbook and all sort of things. Right? So we try to be as specific and as mindful as alerting. And so what we've done so far, we improved Airflow executors, we improved alerting and monitoring, and we improved global DAG validation to make sure that our DAG's sanity maintained. So these are the 3 critical things that we did to make our operation pipelines. So this is one day of on-call engineers experience. You can see, like, okay, it's quiet here, and it's like too little quiet here. So these two lines basically all the hard works the team did for like 3 months, and we ensure that we ship quality code, and seems like he's happy. Right. So what is next? We wanted to increase pipeline visibility. We wanted to, so one of the common complaint we hear is like, okay, somebody clear that task, and who cleared my task? Like somebody shouting like, this is my task, don't clear it. Who clearing the task? So we wanted to get more visibility on that. And the task lifecycle is something that we wanted to see that like, so the, in the unit of data, like retryable sensors, the way Airflow handle right now, handling exception as a failure and then trying to retry, there is no lifecycle code. What I mean that is like, so the retry task basically retry, is that really a failure? It's not. It is just retrying is one stage of the lifecycle, right? So, but the UI shows always like, okay, this task is retrying, this task is failed, and like a very finite defined one, but it is not aligned with what is the actual task lifecycle, right? So it'd be great if somehow we can like segregate and like flaggable scheduler action with the like a task lifecycle. So independently we can define the task lifecycle, then associated with the scheduler action. Then we can give more meaningful information back to the users. What is the stage into this one? So if, for example, like for the retryable sensors, the task is retrying, the user see the task is retrying, but they don't have any, actually what is happening is the success criteria doesn't meet, and there is no life cycle event for the success criteria doesn't meet. Same thing for DQ validations, the DQ check failed, it just failed. It's a very common thing. It is not exact. It is right now Airflow action basically reflect like scheduler action. It is not reflecting any Airflow task lifecycle. The other thing we wanted to do is like data lineage, ability to tie up Airflow task with the table creations, like what are the tables get created, out of which task, and all those things, so that we can understand what is the cost of each and every table and how many people are accessing those tables, and what is our ROI that basically we generate out of our data infrastructure. So that's one of the super critical things that we wanted to do. And looking forward to Airflow Kubernetes executors. This is not necessarily for scaling. I think whatever the retryable sensors that we do, we can run for another 1 year. We are looking for Kubernetes for like a larger other data infrastructure, trying to unify things, and Airflow logically makes the first steps to do that. So yeah, that's it. Thank you. And we're also hiring. Oh, really? Yeah, yeah. Yeah, yeah. I mean, yeah. Yeah, I mean, we look into cellular executors, like, but again, like that brings a cost. Like the CPU and memory is cheap, the code is not cheap. So why should we introduce a new component? Whether instead of running an M4 4x engine, can we just scale up? Then we can see that. Yeah, yeah, totally.
Yeah. So there's a few executors. There's there's three I think that shipped originally with Airflow, and there's the fourth one coming. That's the Kubernetes executor that should probably be used by most or any companies that has Kubernetes instance or cluster. But the way the local executor works, or maybe I'll start with the sequential executor, which is just like meant for testing, and it's just like it will run your DAG one task at a time. And that's used, you know, yeah, just for testing and for debugging. if you want to remove the executor kind of aspect of the testing, you can use that. And local executor is a Python multi-processing queue. So it will fire up a multi-process queue of the size that you specify. So say how many do you have? Do you know how many slots you have on your local executor? So 64 or something. So yeah, so you'll be able to say like, oh, I'll run say 128 slots in my multi-processing queue. So that's a Python construct, and it will just, you know, it's like it runs as part of the scheduler process. Or, you know, if you were to run a backfill job, like an Airflow backfill CLI command, it will run inside your process. So that multi-processing queue is in process, which is kind of scary if you think about it, because you're like running sub-processes into your main process. If the scheduler was to fail, it would lose contact with that queue. And then there's the Celery. So the Celery executor uses this Python library called Celery, which is just a simple-ish abstraction to be able to run remote tasks. So Celery, you would use what they call a broker. So it might be Redis or RabbitMQ. So you'll put the task, a message in a queue that says, please, one of the worker, pick up this task and run it locally. And there's a set of workers that you can fire up. You can fire up as many workers as you want. You can specify queues. And then these workers listen to the message queue. And if a message is intended for their specific queue, maybe you have a single queue, but if you have multiple queues, then it would be like, oh, this is a message for me. I'm just going to pick it up and run it. So that's the way that you scale out, you know, Airflow. And in Celery, I think like we got a lot of mileage out of it. The original intent was to probably write a Yarn executor, but we realized there was a lot of constraint with Yarn. So Yarn being like a resource manager, I think it's called a resource negotiator. It turned out it was really kind of impossible to write a Yarn executor with the constraint that Yarn had. So we would have had to install a lot of libraries and Python code inside the data nodes in our Hadoop cluster, which is a really bad idea. Turns out there's not good containerization support for Yarn, and like that stuff is really a hack. So really, the cube is the thing that everyone's looking at to do that properly. Yes. Yeah, so I had lunch with Danielle. So a guy at Bloomberg is contributing this, and there's an open PR. I think it's like on the verge of getting merged. I'm not sure what's holding up, you know, getting that PR merged, but all the code is there. They're using it. I think they're using it in production at Bloomberg, and then a lot of people, I know Airbnb is looking to use it in production. The idea is not to run Airflow Celery workers inside Kubernetes. It's really to use the Kubernetes API to only use the resources that you need. So I don't know too much about the details, but it kind of functions the way you would imagine it would. So you might have your scheduler in or out of Kubernetes inside a pod, and then that would talk to the Kubernetes API to say like, hey, please spin up you know, an instance and run this. One thing that's important is that I think the path to proper containerization for Airflow is probably Kubernetes. So there's a Docker operator, I believe. So there's a way to run a containerized task, and you know, you can kind of patch and do your own thing in terms of containerization. I would say Airflow containerization was a little bit of an afterthought, where it should probably have been like a foresight, like building Airflow. We should have thought about containers first. Maybe that was done, you know, or that was too early to think about that first. But now I think Kubernetes will allow you for any task that you specify to say, I want to specify a specific Docker instance, and then you would say run this task inside this Docker instance, and then it would run like you would expect it to run in Kube. So yeah, it's right around the corner. If you want to, you can probably use it, you know, today if you want to, and get in touch with Danielle. I don't know if he's online. And hopefully we can get him to give a talk about it again soon.